Yes, let's read, not eat. I've just eat my hot food, so let's read. Yes, I need a minute. I need a minute to get to my bed.
Light-emitting diode. Light-emitting diode lids in red, green, and blue. The LEDs in this picture are housed in regular cases, but there are many variants of LEDs. Working principally electroluminescence invented. J. Round, 1907, 1. Oleg Luzev, 1927, 2. James R. Byard, 1961, 3. Nick Holonyuk, 1962, 4. First production October 1962. Pin configuration: anode and cathode electronic symbol. A light-emitting diode, LED, is a semiconductor device that emits light when current flows through it. Electrons in the semiconductor recombine with electron holes, releasing energy in the form of photons. The color of the light, corresponding to the energy of the photons, is determined by the energy required for electrons to cross the band gap of semiconductor. 5. White light is obtained by using multiple semiconductors or a layer of light-emitting phosphor in the semiconductor device. 6. Appearing as practical electronic components in 1962, the earliest LEDs emitted low-intensity infrared IR light. 7. Infrared LEDs are used in remote control circuits, such as those used with a wide variety of consumer electronics. First visible light LEDs were of low intensity and limited torque. Early LEDs were often used as indicator lamps, replacing small incandescent bulbs, and in 7-segment displays. Later developments produced LEDs available in visible ultraviolet, UV, and infrared wavelengths, with high, low or intermediate light output, for instance white LEDs suitable for room and outdoor area lighting. LEDs have also given rise to new types of displays and sensors, while their high switching rates are useful in advanced communications technology with applications as diverse as aviation lighting, fairy lights, strip lights, automotive headlamps, advertising, general lighting, traffic signals, camera flashes, light-head wallpaper, horticultural grow lights, and medical devices. 8. LEDs have many advantages over incandescent light sources, including lower power consumption, longer lifetime, improved physical robustness, smaller size, and faster switching. In exchange for these generally favorably attributes, disadvantages of LEDs include electric limitations to low voltage and generally to DC, not AC, power, inability to provide steady illumination from a pulsing DC or an AC electrical supply source, and lesser maximum operating temperature and storage temperature. Parts of a conventional LED. The flat bottom surfaces of the anvil and post embedded inside the epoxy act as ensures to prevent the conductors from being forcefully pulled out via mechanical strain or vibration. Close-up image of a surface mounted close-up of an LED with the voltage being increased and decreased to show a detailed view of its operation. As a transducer of electricity into light, LEDs operate in reverse of photodiodes. History, discoveries and early devices. Electroluminescence as a phenomenon was discovered in 1907 by English experimenter H.J. Round of Marconi Labs, using a crystal of silicon carbide and a cat's whisker detector. 9-10. Russian inventor Oleg Luzev reported the creation of the first lead in 1927. 11. His research was distributed in Soviet, German and British scientific journals, but no practical use was made of the discovery for several decades, partly due to the very inefficient light-producing properties of silicon carbide. The semiconductor Luzev used. 12-13. In 1936, Georges Distriau observed that electroluminescence could be produced when zinc sulfide, ZNS, powder is suspended in an insulator and an alternating electrical field is applied to it. In his publications, Distriau often referred to luminescence as Luzev light. Distriau worked in the laboratories of Madame Marie Curie, also an early pioneer in the field of luminescence with research on radium. 14-15. Hungarian Zoltán Bay together with György Szijjártó preempted lighting in Hungary in 1939 by patenting a lighting device based on silicon carbide, with an option on boron carbide, that emitted white, yellowish white, or greenish white depending on impurities present. 16. Kurt Lehovec, Karl Accardo, and Edward Jangoshan explained these first LEDs in 1951 using an apparatus employing SiC crystals with the current source of a battery or a pulse generator, and with a comparison to a variant, pure, crystal in 1953. 17-18. Reuben Braunstein, 19, of the Radio Corporation of America reported on infrared emission from gallium arsenide, GaAs, and other semiconductor alloys in 1955. 20. Braunstein observed infrared emission generated by simple diode structures using gallium antimonide, GaSb, GaAs, indium phosphide, InP, and silicon germanium, SiGe, alloys at room temperature and at 77 kelvins. In 1957, Braunstein further demonstrated that the rudimentary devices could be used for non-radio communication across a short distance. As noted by Kroemer, 21, Braunstein had set up a simple optical communications link, music emerging from a record player was used via suitable electronics to modulate the forward current of a GaAs diode. The emitted light was detected by a PBS diode some distance away. Modern LED retrofit with E27 screw-in base. A bulb-shaped modern retrofit LED lamp with aluminum heat sink, a lighter fusing dome and E27 screw base using a built-in power supply working in mains voltage. Green electroluminescence from a point contact on a crystal of SiC creates Round's original experiment from 1907. This signal was fed into an audio amplifier and played back by a loudspeaker. Intercepting the beam stopped the music. We had a great deal of fun playing with this setup. This setup presaged use of LEDs for optical communication applications. A 1962 Texas Instruments SNX 100 GaAs LED contained in a 218 transistor metal case in September 1961, while working at Texas Instruments in Dallas, Texas. James R. Byard and Gary Pittman discovered near-infrared, 900 nm, light emission from a tunnel diode they had constructed on a GaAs substrate. 7. By October 1961, they had demonstrated efficient light emission and signal coupling between a GaAs p-junction light emitter and an electrically isolated semiconductor photodetector. 22. On the 8th of August 1962, Byard and Pittman filed a patent titled Semiconductor Radiant Diode based on their findings, which described a zinc-diffused p-n junction LED with R-spaced cathode contact to allow for efficient emission of infrared light under forward bias. After establishing the priority of their work based on engineering notebooks predating submissions from G.E. Labs, RCA Research Labs, IBM Research Labs, Bell Labs and Lincoln Lab at MIT. The U.S. Patent Office issued the two inventors the patent for the GAAS infrared light-emitting diode, U.S. Patent US 3293513, the first practical LED.7. Immediately after filing the patent, Texas Instruments, T, began a project to manufacture infrared diodes. In October 1962, T announced the first commercial LED product, the SNX 100, which employed a pure gas crystal to emit an 890 nm light output. 7. In October 1963, T announced the first commercial hemispherical LED, the SNX 110. 23. The first visible spectrum, red, LED was demonstrated by J.W. Allen and R.J. Cherry in late 1961 at the SEL in Baldock, UK. This work was reported in the Journal of Physics and Chemistry of Solids, Volume 23, Issue 5, May 1962, pages 509-511. Another early device was demonstrated by Nick Holonyuk on October 9, 1962, while he was working for General Electric in Syracuse, New York. 24. Holonyuk and Bevilacqua reported this LED in the journal Applied Physics Letters on December 1, 1962. 25. 26. M. George Crayford, 27, a former graduate student of Holonyuk, invented first yellow LED and improved the brightness of red and red-orange LEDs by a factor of 10 in 1972. 28. In 1976, T.P. Pearsall designed first high-brightness, high-efficiency LEDs for optical fiber telecommunications by inventing new semiconductor material specifically adapted to optical fiber transmission wavelengths. 29. Initial commercial development. Until 1968, visible and infrared LEDs were extremely costly, in the order of US $200 per unit, and so had little practical use. 30. The first commercial visible wavelength LEDs were commonly used as replacements for incandescent and neon LED display of a T30 scientific calculator, c. 1978, which uses plastic lenses to increase the visible digit size. 8 small rectangular blobs, which are the digits, connected by fine hair-like wires to tracks along a circuit board. X-ray of a 1970s 8-digit LED calculator display indicator lamps, and in 7-segment displays. 31. First inexpensive equipment such as laboratory and electronics test equipment, then later in such appliances as calculators, TVs, radios, telephones, as well as watches. Hewlett-Packard, HP, was engaged in research and development, R&D, on practical LEDs between 1962 and 1968, by a research team under Howard C. Borden, Gerald P. Piani at HP Associates and HP Labs. 32. During this time HP collaborated with Monsanto Company on developing the first usable LED products. 33. First usable LED products were HP's LED display and Monsanto's LED indicator lamp, both launched in 1968. 33. Monsanto was the first organization to mass-produce visible LEDs using gallium arsenide phosphide, GaAsP, in 1968 to produce red LEDs suitable for indicators. 30. Monsanto had previously offered to supply HP with GaAsP, but HP decided to grow its own GaAsP. 30. In February 1969, Hewlett-Packard introduced the HP model 5082-7000 numeric indicator, the first LED device to use integrated LED circuit, technology. 32. It was first intelligent LED display, and was a revolution in digital display technology, replacing the Nixie tube and becoming the basis for later LED displays. 34. In the 1970s, Commercially successful lead devices at less than 5 cents each were produced by Fairchild Optoelectronics. These devices employed compound semiconductor chips fabricated with the planar process, developed by Jean Hoerni, 36. The combination of planar processing for chip fabrication and innovative packaging methods enabled the team at Fairchild, led by optoelectronics pioneer Thomas Granto, achieve the needed cost reductions. 37. Net producers continue to